Next, we have Charles' Law. So, what is Charles' Law? Charles' Law is also sometimes referred to as the law of volumes. Ano pong ibig sabihin nun? Sabi dyan, when there is a decrease in temperature, it will lead to a decrease in volume. Or basically, the temperature is directly proportional to the volume. So, ito yung ating equation kapag we are talking about Charles' law. So, T is directly proportional to the volume, or as temperature increases, volume also increases. And as temperature decreases, volume also decreases. Again, in order for us to remove this proportionality sign, we are going to introduce a proportionality constant, C. So, our equation is equal to T is equal to C times V. And ang ititira ulit natin dun sa right side ng equation is yung constant C. So, dividing both sides by V, we have T over V is constant. So, again, lalagyan lang natin ito ng subscript para makita lang natin yung relation ng temperature and volume initially dun sa temperature and volume after mag-undergo ng process ng isang ideal gas. So, T1 over V1 is equal to T2 over V2. Yun lang yung ibig sabihin nito. Or, para mas maganda siguro tingnan, i-cross-multiply natin to pagsamahin natin yung volume. V2 over V1 is equal to T2 over T1. So, ito na yung ating equation under Charles' law. Volume is directly proportional to the temperature. So, kung meron tayong given conditions at point 1 and at point 2, pwede nating masolve yung unknown na property. Okay, so let us solve one example about Charles' law. Again, let me read yung ating problem. Okay, so example problem, we have, halin kaya dito yung maganda. Halos lahat naman ay simple, iba-iba lang ng unknown. Okay, so ito na yung i-try natin. A container holds 50 milliliters of nitrogen at 25 degrees Celsius and a pressure of 736 millimeters of mercury. What will be its volume if the temperature increases by 35 degrees Celsius? So first, ililista ko muna dito yung mga given na properties. Okay, so ito na yung mga given. Initial volume is 50 ml, initial temperature is 25 degrees Celsius, and the pressure is 736 millimeters of mercury. What is the volume? The final volume, V2, if the temperature increases by 35. Mamakala ko ba 35? Bakit 60 ang sinulat mo? Kasi ang sabi doon, increases by. So, tumaas ng 35. So, yung 25, paplasan natin ng 35 equivalent sa 60 degrees Celsius. Iba yung increase by, iba yung increase to. Kapag increase by, yung initial temperature, paplasan natin kung ilan yung ini-increase. Kapag increase to, yun na mismo yung final na property. Okay, so to solve for V2, since constant yung pressure, apply natin yung Charles' law. So, ito yung ating equation. V2 over V1 is equal to T2 over T1. Pero, take note, bawal tong kalimutan, kapag pinag-uusapan natin ng ideal gas law, dapat yung pressure and yung temperature na isa-substitute nyo dun sa equation ay absolute. So, pag sinabi kong absolute temperature, either naka-degrees Kelvin or naka-degrees Rankine. And since yung given natin ay naka-degrees Celsius, we can convert this into degrees Kelvin. Again, para maging degrees Kelvin yan, paplasan lang natin ng 273. So, isusulat ko na lang kung ano nang equivalent niya sa Kelvin. 25 plus 273 is 298 Kelvin. So, 25 degrees Celsius is equivalent to 298 Kelvin, while 60 degrees Celsius plus 273 is 333 Kelvin. So, 333 Kelvin. Dapat wag niyong kalimutan na naka-absolute yung temperature. Kapag hindi absolute, mali ang sagot. So, V2, para masolve natin si V2, by cross multiplication, itataas lang natin tong V1 dito. So, magiging formula natin is T2 over T1 times V1 or T2 V1 over T1. Substituting the values, we have T2 333 Kelvin T1, 298 Kelvin, and V1 equivalent to 50 milliliters. Now, makakancel out si Kelvin. So, V2 is equivalent to 333 divided by 298 times 50. So, equivalent sa 55.8725 or 55.87 milliliters or ml. Now, ito na yung ating final answer. Again, depende kung alin yung unknown. So, imamanipulate nyo lang itong equation, depende kung alin yung hinahanap sa problem. So, kapag pressure is constant, temperature is directly proportional to volume. That is according to Charles' law. So, that's all. Thank you.